Hello everyone, welcome to Management Information Systems, Managing the Digital Firm. This is going to be our introductory conversation regarding Chapter 6, which is the Foundations of Business Intelligence, Databases and Information Management. Now keep in mind, this is just a precursor conversation or introductory conversation to the expanded conversation that we'll have in a classroom, just to introduce you to and familiarize you with the chapter. Okay, so our learning objectives for this chapter is going to be trying to answer the questions, what are the problems of managing data resources in a traditional file environment? What are the major capabilities of database management systems, otherwise known as DBMS, and you'll hear me refer to them as DBMS throughout the presentation. And why is a relational DBMS so powerful? We also want to find out what are the principal tools and technologies for accessing information from databases to improve business performance and decision making, and why are information policy, data administration, and data quality assurance essential for managing a firm's data resources. So let's get started here. So now this slide describes a hierarchy of data that is used to store information in a database, progressing from the database as the top level holder of information down through the field, which stores information about an entity's attribute. So the hierarchy is illustrated by this graphic. And here we see a computer system really organizes data in a hierarchy that starts with the bit, which represents either a 0 or a 1. Now bits can be grouped to form a byte to represent one character, number, or symbol. Bytes can be grouped to form a field, and related fields can be grouped to form a record, and related records can be collected to form a file, and related files are organized into a database. So now this example gives a student course file. So if we take a look at this really quickly, we see the bit represented by a 0. The byte is represented by a letter, right? This sequence, the 01001001, actually makes the letter I, right? And then you have the field, which is the IS 101, and the record, which makes the student record, right? And from the student record, we see a culmination of files, separate files, and then from the file, it goes into the database, and then it's an aggregated information in its proper place, right? So you have your course file, personal file, and finance file. So what are some of the problems with traditional file environment, or the traditional file environment? So now this slide really discusses or opens up the opportunity for discussion regarding the problems in data management that occur in a traditional file environment. So in a traditional file environment, different functions in the business, such as accounting, finance, HR, marketing, sales, they're all in traditional file management. They're all maintained in their own separate files and databases for each separate department. Now this creates an opportunity for data redundancy, which is like duplicate data and multiple data files, and it really wastes storage and leads to data inconsistency. Now data inconsistency is the replication of data stored in different locations, which can lead to updates in some systems or files but not others. So you're going to get inaccurate data there. Then you have program data dependence. Now, what this is it really describes the close relationship between data stored in files and the software programs that update and maintain those files. And and any change in the software program could require a change in the data accessed by that program. Now, the lack of flexibility is really traditional file systems that can deliver routine scheduled reports with programming, but can't deliver ad hoc reports or respond to unanticipated information requirements. Poor security, of course, is little control or management of data, or who is changing the information within the system. And then you have the lack of data sharing and availability because of the lack of seamless information sharing between departments. The immediate availability of correct and updated information between departments is really limited in this scenario, and the use of the traditional approach of file processing really encourages each department of an organization to develop specialized application. Each application requires a unique data file that is likely to be a subset of the master file, and then the subsets lead to data redundancy, inconsistencies, processing inflexibility, and wasted storage resources. Now, DBMS consists of software that really permits an organization to centralize data, manage it efficiently, and provide access to that data by application programs by both logical and physical views. Which we'll talk more about in class, but relational DBMS are the most common type of DBMS in use with PC servers and mainframes. Relational DBMS represents data as really two-dimensional tables called relations, and each table contains data on an entity and its attributes. Now, this slide describes how information is retrieved from a relational database. These operations, select, join, project, are like programming statements and are used by the DBMS developer. There are three main capabilities of a DBMS. It's data definition capability, the data dictionary, and a data manipulation language. Now, data definition is simply the ability to specify the structure of the content DB and is used to create DB tables and to define the characteristics of the fields. Data dictionary is an automated or manual file that stores definitions of data elements and their characters. And the data manipulation language is a specialized language used to add, change, delete, or retrieve the data in the database. Now note that the data manipulation language is the tool that requests operations such as select, join, to actually be performed on the data. So now here we describe activities involved in designing a database. So to create an efficient database, you must know what the relationships are among the various data elements, the types of data that will be stored, and how the organization will need to manage the data. So note that the conceptual database design is concerned with how the data elements will be grouped and what data in what tables will make the most efficient organization. Business intelligence is a very amorphous notion that is not well defined. So this slide discusses the use of data warehouses and data marts by firms. Data warehouses are DBs that stores current and historical data of potential interest to decision makers throughout the company. It extracts current and historical data from multiple OS or operating systems inside the organization. Data is available for anyone to access as needed but can't be altered. It provides a range of ad hoc and standardized query tools, analytical tools, and graphical reporting facilities as well. Now, the data marts are really smaller data warehouses. They're smaller, decentralized warehouses with a summarized or highly focused portion of the organization's data and is placed in a separate database for a specific population of users. Then you have the Hadoop, which is an open source software framework managed by the Apache Software Foundation that enables distributed parallel process of huge amounts of data across inexpensive computers. It handles unstructured and semi-structured data in vast quantities. Now in memory computing, memory computing is useful for facilitating big data analytics, which relies primarily on a computer's RAM for data storage. It shortens the query response time by storing it on the RAM and allowing for complex calculations to be completed in seconds. Now, analytic platforms are specialized high-speed platforms using both relational and non-relational technology optimized for analyzing large data sets. Once data has been captured and organized, it is available for further analysis using the following. So you have the multidimensional data analyst, which is the OLAP. You have the data mining, text mining, web mining, and let's look at those a little deeper. So the online analytical processing, or the OLAP, supports multidimensional data analysis. It enables users to view the same data in different ways using multiple dimensions. And if we look at this figure, this visual that we have here of a multidimensional data model, this view really shows product versus region. So we see product, we see region, right, here and here, and then we see annual and projected right here. But it really shows product versus region, and if you rotate the cube 90 degrees, the face that will show is product versus actual and projected sales. If you rotate the cube 90 degrees again, you will see regional versus actual and projected sales. Other views, of course, are possible. Now, this graphic illustrates the concept of dimensions as it relates to data. Product is one dimension. East is a dimension, and projected and actual sales are two more dimensions. Altogether, we are trying to analyze 4 dimensions, sometimes referred to as a data cube. The graphic can depict this 4-dimensional view of the data. More importantly, when compared to a spreadsheet model of the same data, a graphical data cube is much faster and easier to understand and visualize the relationships. So just for example, if the business question is in the eastern region, what are the actual and projected sales of our products? So we have the products, we have actual and projected, and then we have the regions. So our regions are running vertically. Our products are running horizontal, as well as we have the actual and projected. So if we wanted to try to answer that question, of course we don't have any data, so we can't get any hard numbers, but if we wanted to answer the question of the eastern region and the actual and projected sales of our product, we're going to go vertical, right, with that information, and then if we flip it, we can go horizontal here to get our information. And that is a multidimensional data model. Now, data mining is discovery driven, and it provides insights into data that can't be discovered through OLAP by inferring rules from patterns in data. Obtainable information from data mining includes associations, which are occurrences linked to a single event, sequences, which are events linked over time, classification, which recognizes patterns that describe groups to which items belong, clustering, which is similar to classification when no groups have been defined. It finds groupings within data, and forecasting, which uses series of existing values to forecast what other values will be. Whereas data mining describes the analysis of data and databases, there are other types of information that can be mined, such as text mining and web mining. And now we'll discuss this a little bit more in class. But then our last slide looks at how companies really utilize the web to access company databases. So now there are many companies that use the web to make some internal databases available to customers or partners. You know, they would have they could have a private intranet, and then the information that they do want to share, they can make that public on the web. The typical configuration includes a web server, application server, middleware, CGI scripts, database servers, or hosting, DBMS. And the advantages of using the web for database access is ease of use of browser software. Web interface requires few or no changes to the database, and inexpensive to add web interface to the system. Now, this was our last slide. I can't wait to see you guys in class to continue this discussion. And until next time, bye-bye.